Hello, I am Ramakrishna Reddy Palagiri and welcome to my channel Vegetable Oils and Fats. And this video is I made about linoleic acid, which is a polyunsaturated fatty acid. We can find this oil in groundnut oil, soya oil, sunflower oil, like that. It is a omega-6 fatty acid also. So in this video, I have explained the in which oils this fatty acid abundantly available, the physical properties of this fatty acid and uses of this fatty acid is given in this video. Please view the video and give your suggestions. If you like the video, and if you not subscribed it, please kindly subscribe my video. At the same time, your friends who are working in oil industry also suggest them to view this video and subscribe the video. When you are viewing the video, below you can see a subscribe button. So please kindly press that button so you will be get subscribed to my channel. Your support is more important because I have to make more videos. I like and I require more subscribers to reach more people. So please subscribe the video. At the same time, recommend to your friends who are working in your oil industry. Okay, thank you. Linoleic acid. It contains 8 carbons and 2 double bonds. It is known as 9Z, 12Z, octadeca, 9, 12 ionic acid. Octadeca means 18 carbons. Ionic means 2 double bonds, 9 and 12 double bonds. It is also called as cis 9, 12, octa, deca, ionic acid. It is a polyunsaturated fatty acid. Here, the chemical formula of the linoleic acid is given. This is the first carbon of the hydrocarboxylic chain, and it is also carboxylic group. It contains COH, and this one is the last carbon known as the omega carbon. It is a methyl group. Linoleic acid is a long chain polyunsaturated fatty acid which contains 2 double bonds, one at 9th and second one at 9th carbon of fatty acid of hydrocarbon chain. The fatty acid known as omega-6 fatty acid because when we count double bond at 12th carbon from omega carbon, that is methyl group last carbon of chain, it is formed at 6th carbon of the chain. Here this double bond position is shown here. It is the carboxyl group, first carbon, 7, 8, 9. This is between 9th and 10th carbon. Again is 12th and 13th carbon. Linoleic acid is a colorless liquid and insoluble in water. At the same time, it is soluble in many hydrocarbon solvents, which are also known as the organic solvents. So, it is soluble in many hydrocarbon solvents like ether, ethanol, and chloroform. It is presumed that in metabolism, alpha linoleic acid is converted into arachidonic acid and docosahexaenoic acid. Arachidic acid is a saturated fatty acid with 20 carbons. Here it is arachidonic acid. Arachidonic acid is a polyunsaturated fatty acid. It contains 4 double bonds and its last bond out of this 4 one is on the 6th carbon from the omega carbon. That is why it is a omega-6 fatty acid. So this linoleic acid may be converted as arachidonic acid or docosahexaenoic acid. Docosa tetraenoic case means docosa means 22, tetra means 4. So it contains 22 carbons and 4 bonds. It is also a omega 6 fatty acid. Here, structural images of linoleic acid is given here below. This is the 2D structure of the linoleic acid, and this is the carboxylic group CO double bond and COH, and this one is the last carbon methyl group and omega carbon, and here we can see 2 double bonds. This is the, when we counted from the carboxy group, it is the between 9th and 10th carbon, this is a double bond, and this is a double bond between 12th and 13th carbon. So, and this one you can see here at 9th carbon and 10th carbon, the 2 carbons are the at same side. Both are at same side of the 2 carbons, and this second double bond also at the same side of the 2 carbons at double bond. So this fatty acid contains cis configuration, cis and cis. Both are also in cis and cis configuration. Here, some oils which contain linoleic acid is given here below. Safflower oil, fatty acid is present in safflower oil from 75 to 78%, and in grapeseed oil 70% to 73%, in poppy seed oil 68 to 70%, in sunflower oil 68% to 70%, and hemp seed oil 58% to 60%, in corn oil 55 to 59%, in wheat germ oil 53% to 55%, in cotton seed oil 52% to 55%, in soybean oil from 50% to 52%, in walnut oil 48 to 51%, sesame oil is 42 to 45%, and in rice bran oil is 35 to 40%. In pista oil, it is between 30% to 33%. In peanut oil, it is between 30% to 35%. In canola also, it is between 30% to 31%. And in linseed oil, it is between 12 to 15%. In egg oil, we can see it is 15% to 16%. And in lard animal fat, we can see it is at the 8% to 10%. And in palm oil, it is present between 8% to 10%. In cocoa butter, it is between 2.5 to 3%. In butter, it is between 1.5 to 2%. In coconut oil, it is between 1.5 to 2%. And in macadamia oil, it is between 1.5 to 2%. Physical properties of linoleic acid. Molar mass 280.42 grams per mole. Appearance of the fatty acid, colorless liquid. And density 0.902. And melting point minus 12 degrees centigrade. Boiling point 360 degrees at atmospheric pressure, and 220 degrees at 16 mm pressure, mercury pressure. Refractive index 1.469 to 1.471 at 15 degrees centigrade. Flash point 112 degrees centigrade. And soluble ether, ethanol, carbon tetrachloride, organic solvents. Linoleic acid is the most favored fatty acid used in cosmetic and personal care products, as it can't be synthesized by the body and always used as emollients for moisturizers for skin, nails and hair. Linoleic acid is an essential, means indispensable, nutrient that contains 2 double bonds at the 9th and 12th carbons from the carbonyl functional group. Because human can't incorporate a double bond beyond the 9th carbon of a fatty acid. This fatty acid can't be synthesized and thus must be consumed externally. Means that we have to use oils which contains linoleic acid, which is also known as the omega-6 fatty acid. The main destination of linoleic acid are applications in the production of alkyd resins and epoxy esters with little tendency to yellowing by air drying and oven, used in moisturizers, pigments, soft soaps, and art printing binders, ink binders. And furthermore, it is also used as raw material in the manufacture of emulsifiers, fatty acid esters, fatty acid amides, fatty acid alcohol amides for detergents, insecticides, and pharmaceuticals. By total hydrogenation, it is converted as stearic acid. Whereas we require stearic acid, folic acid, and linoleic acids are converted by hydrogenation into stearic acid. These are the some uses of the linoleic acid.